Good afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, we are going to study again some more examples based on homogeneous differential equations. So, in yesterday's class, also we have solved some NCERT problems. Today, also, we will solve some more initial value problems with respect to homogeneous differential equation. Right? Let's see the first example. It is homogeneous, right? Homogeneous differential equation. Right. Example 1. All examples are based on NCERT only, so it is quite easy to solve, you people. So, first example is solve the differential equation. Solve a differential equation x plus y dy plus of x minus y dx, which is equals to 0, given that y equals to 1 when x equals to 1, right? So, solution. So, first we have write down the given. We have x plus y dy plus of x minus y dx, which is equals to 0, which implies now we can write it in the standard form. That is dy by dx, which is equals to, just a basic simplification is there, y minus x upon y plus x, it is, right? So dy here only, this term goes on RHS, and the minus sign, if you multiply, it becomes y minus x and y plus x or x plus y, right? So now take it as this equation 1. Now this is a linear homogeneous differential equation. This is a linear homogeneous differential equation, right? How it is linear differential equation? Where in the numerator is degree 1, in the denominator is also degree 1. If we apply lambda x and lambda y in place of x and y, again we get a degree is 1, therefore we are calling it as first order. That is nothing but linear. Linear means the order degree must be 1, right? Therefore it is a linear homogeneous differential equation. Simply we can say homogeneous differential equation, because in the numerator of equation 1 as well as in the denominator, the degree must be same. Then only we can say it's a homogeneous differential equation. So now after it is homogeneous, put y equals to v of x, right? Put y equals to v of x, and dy by dx is already you know well, u into v form. Just keep in mind v x dv by dx. In equation 1 we get, let's see, that is v plus x dv by dx, v plus x dv by dx, which is equals to y minus x is there, right? It is vx minus x divided by y plus x is there, vx minus of vx plus of x, it is, right? So which is equals to, if you take x common from numerator as well as denominator, x get cancelled from both the terms. Only what we get here, by taking x common, here both x get cancelled. The remaining terms are v minus 1 upon v plus 1, right? So now again, which implies by taking v on right side, that is x dv by dx remains now v minus 1 upon v plus 1 minus of v, right? So now again, which is equals to cross multiply this, what you get here, v minus 1 is as it is, again here v is there, v plus 1, right, divided by v plus 1, again which is equals to v minus 1 minus of v square minus of v, right? Here minus v plus v get cancel. The remaining term is, that is x dv by dx, which is equals to, here I am taking minus common, which is equals to minus common, I can write it as v square plus of 1 upon v plus 1, right? Now separating the variables. Separating variables v and x. Then we have v plus 1 upon v square plus 1 into dv plus of, this minus goes on LHS, again it becomes what, dx upon x. A basic calculation is here, just taking separately, which is equals to 0, right? Now integrate, we get integrating, we get integration of v, so taking separately here, v upon v square plus 1 dv plus integration of dv upon v square plus 1 plus of integration of dx upon x, which is equals to 0, right? So now here, to convert this term into the standard form, we are multiplying and dividing by 2 here, right? So 1 by 2 2v upon v square plus 1 dv plus dv upon v square plus 1 into dx upon x, which is equals to 0. So after integrating, what we get here, it is now in the standard form. V square is f of x here, this 2b is f dash of x, right? So 1 by 2 as it is after integration, log of v square plus 1, this term goes tan inverse of v, right? It is 1 upon x square plus 1, right? 1 plus x square, which is equals to log x. If you want, you can write here, because 1 upon 1 plus x square is tan inverse x, right? Second term, which is equals to c, constant c. So now, which implies, now taking 1 by 2 common from both the terms here, the log terms, here is also, it is log x is there, it is 1 by 2 log v square plus 1 is there, right? So what we are doing here, 1 by 2 taking common means we have to write log of v square plus 1 into what, x square, because here x is there, 1 by 2 is common for both the terms, that is log v square plus 1, so it is in the new base only, 1 by 2 log v square plus 1. For x square, if we take 2 to the denominator, 2 by 2 get cancelled, again what we get here, x square, right? Just by taking 1 by 2 common here, for that reason x becomes x square, right? So plus tan inverse of v, which is equals to c, right? Take it as equation 2. Now putting the value of v in equation 2, putting the value of v in equation 2, we obtain it is 1 by 2 as it is log of v means y square by x square here, y equals to vx, right? So y square by x square plus 1 into x square plus tan inverse of y by x, which is equals to c. So 1 by 2 log of cross multiply this, what we get here, y square plus x square upon x square into x square plus tan inverse of y by x, which is equals to c. Here x square get cancelled. 1 by 2 log of y square plus x square plus tan inverse of y by x, which is equals to c, right? So take it as equation 3, that is 1 by 2 log y square plus x square plus tan inverse of y by x, which is equals to c. Take it as equation 3. On putting x equals to 1 and y equals to 1, we have, on putting x equals to 1, y equals to 1, we have 1 by 2 log of 2, it is y square plus x square, both are 1 here, it is also 1, it is also 1, and plus tan inverse of 1 by 1 is tan inverse 1, which is equals to c. Therefore, which implies c equals to 1 by 2 log 2 plus of tan inverse 1 is pi by 4, because tan inverse 1 is pi by 4, right? So now putting the value of c in equation 3, putting the value of c in equation 3, we get this equation 3 is 1 by 2, it is log of y square plus x square plus of tan inverse y by x, which is equals to, just substitute the value of c, it is 1 by 2 log 2 plus of pi by 4, right? So now which implies log of y square plus x square. By taking here what, 1 by 2 common, just take 1 by 2 common here, 1 by 2 log of y square plus x square, right? It is a common. Tan inverse y by x is there, so what we get here by taking 1 by 2 common, 2 tan inverse y by x, right? Similarly here also by taking 1 by 2 common inside, what we get, log 2 plus pi by 2, right? So this 1 by 2, this 1 by 2 get cancelled from both LHS and RHS. The remaining term is log of y square plus x square. Now this term taken to the LHS, that is log term, one side, it is minus of log to this term, it is log 2, which is equals to pi by 2 minus this term goes on RHS, 2 tan inverse y by x, right? So now log m minus n form, right? Log m by n is nothing but y square plus x square upon 2, which is equals to pi by 2 minus 2 tan inverse y by x, which is required solution of equation 1. Which is required solution of equation 1, right? So next example, is example 2. Solve the differential equation x square dy plus y into x plus y dx, which is equals to 0, given that y equals to 1 when x is equals to 1. So it is asked in CBSE 210. It is 2K10, right? In 2010, this question has been asked in the board exam. So solution for this, write on the given differential equation once again in solution part. We have x square dy plus y x plus y dx, which is equals to 0. So now convert it in the standard form, which implies dy by dx, which is equals to minus of y times x plus y dividing by x square, right? A basic simplification is there. Simply just alternating LHS and values to RHS. Let us take it as equation 1. So which is linear homogeneous differential equation again, because here also what we are getting here, the order is what? Degree is 2 only here in the numerator is also degree is 2, and as well as in the denominator is also it's a degree 2. Therefore it's a homogeneous differential equation. It is homogeneous differential equation, right? So now put y equals to vx, which implies dy by dx, which is equals to v plus x dv by dx. In 1 we get, so the first substitute the value here in equation 1. Let's see what we get here. V in place of dy by dx, what we get here, v plus x dv by dx, which is equals to minus as it is, y means vx, again x plus y means vx upon x square. So here by taking x square common and get cancel x square from both numerator and denominator, what we get, I'm writing it directly. See, if you take x common in these two terms, what we get here, 1 plus v inside and vx is there here. So just take common, what we get here, x square inside, what we get, minus v 1 plus of v upon x square. Here x square get cancelled, remaining term is minus v 1 plus v, right? So now take this plus v to the RHS, it becomes x dv by dx, which is equals to minus v 1 plus of v minus v, right? So what we get here, x dv by dx, it is minus v, it is minus v square minus v. So what we can write it here, So x dv by dx, x dv by dx, which is equals to minus 2v minus v square, right? So by taking x dv by dx, by taking minus v common here, what we get inside? 2 plus of v, right? So now variable separable, separating variables v and x, we get dv upon v 2 plus v. Again minus is there here. If you take dx upon x, again LHS, it becomes plus dx upon x, which is equals to 0, right? Integrating we get integration of dv upon v 2 plus of v plus of integration of dx upon x, which is equals to 0, right? After integrating, what we get, let's see here. To integrate, before integration we can do here partial fraction, that is taking 1 by 2 outside here, just the alteration, the first term, what we can writing here, 1 by v minus 1 upon v plus of 2 into dv plus integration of dx by x is log x, which is equals to log c by partial fraction, right? Again, if you simplify this, what you get here, 1 upon v 2 plus v, right? So simply see here, if you cross multiply this, what you get here in the denominator LCM is v plus of 2. If v get cancelled, what we get here v plus of 2 minus here v plus 2 get cancelled, means it is v. So outside 1 by 2 is the right. So 1 by 2 as it is, plus v minus v get cancelled, and this 2 remains, 2 get cancelled. Again what we get here, 1 upon, simply if you write what we get here, 2 v plus of 2 means here 2 get cancelled, the remaining term is 1 upon v plus 2, right? So the next step we are going to solve here, which is equals to, now different integrate this one, 1 by 2 as it is, log v minus of log v plus of 2, right? Plus log x, which is equals to log c. So again m minus n can be written as 1 by 2 as it is, log of v upon v plus of 2 plus log x, which is equals to log c. So again, which implies by taking 1 by 2 common here also, if you take 1 by 2 common, what you get here, log v upon v plus 2 plus 2 log x, which is equals to log c. Now they take this 2 on RHS, it becomes log v upon v plus 2 plus 2 log x, which is equals to 2 log c, right? So now again which implies log of v upon v plus of 2, this 2 log x can be written as, by using logarithm property, log x square, which is equals to here also log c square, right? So now which implies log v upon v plus 2 log x square here, log k we can say, because where k is c square, right? Where k is c square, simply, which implies it is log m plus n again, log mn, log of which can be written as vx square upon v plus of 2, which is equals to log k, right? Here logarithm property we have used. Log m plus n can be written as log mn. So log get cancelled from both the sides. The remaining is vx square upon v plus 2, which is equals to k. Take it as equation 2. Again, which implies vx square by v plus 2, which is equals to k. So putting the value of v, putting the value of v in equation 2, we have just substitute the value here. What we get, let's see, that is yx upon y by x plus 2, which is equals to k, because y equals to what here? Y equals to vx is there here in the numerator, vx square is there, so xx get cancelled, only yx remains in the numerator, in the denominator y by x plus 2 equals to k, right? So again, which implies cross multiply in the denominator, what we get, yx upon y plus 2x whole divided by x, which is equals to k. So again, which implies yx upon y plus 2x, this term goes on, numerator becomes yx square upon y plus 2x, which is equals to k. So x square y, which is equals to k times of y plus 2x, right? So now take it as equation 3. Given here y equals to 1 when x equals to 1, putting these values in 3, we get, so x square y square, x is also 1, y is also 1, therefore it is 1, which is equals to k. Y is 1, x is 1 means 1 plus 2. So what we get here, k equals to, it is 3, it becomes, goes on LHS, k equals to 1 by 3. Putting k equals to 1 by 3 in equation 3, we get, so x square y as it is, which is equals to value of k is 1 by 3, y plus of 2x is nothing but our required solution of equation 1, right? So next, one more example. Examples are lengthy but very easy. If you once understand the method, then you can solve any problem. So the next problem is solve example 3. Solve the differential equation. Solve the differential equation x sine square y by x minus of y dx plus x dy, which is equals to 0, given that y equals to pi by 4 when x equals to 1, right? So now solution for this one, we have, first let us consider the given x sine square y by x minus of y dx plus x dy, which is equals to 0. So now we have to convert this in the standard form. It is dy by dx, which is equals to x dy by dx, which is equals to minus x sine square y by x plus of y, right? So now again dy by dx, which is equals to minus sine square. If you take x on RHS here, x get cancelled in the first term. Only what we get, minus sine square y by x plus y by x, right? Now it is in the standard form, dy by dx, which is equals to minus sine square y by x plus y by x, right? So now take it as equation 1. So now put, again this is also homogeneous only, right? So put y equals to bx so that dy by dx, which is equals to e plus of x dv by dx. So just substitute the values here in the equation 1 in 1, and then v plus x dv by dx, which is equals to minus sine square of v, right? Y by x means v here, plus again v. So this term can be become plus this plus get cancelled from both the LHS and RHS. What we get, x dv by dx, which is equals to minus of sine square v. So again, which implies if sine square take on LHS, it comes to the denominator. So minus cosec square of v into dv, variable separable here, right? So in RHS, what we get, dx upon dx, that is variable separable of v and x, right? So now integrating this term, so now integrating we get, it is integration of minus cosec square y dv, which is equals to integration of dx upon x. So integration of minus cosec square v is cot v, right? It is integration of minus cosec square x is this is cot x, right? Similarly, cot v, which is equals to log x plus of c, right? So now cot v equals to log x plus c as it is. Now put value of v, put value of v in, it is equation 2, in 2 we get, right? Now substituting the value of b, that is nothing but equation 2 becomes cot of y by x log x plus of c. It is equation 3. Now putting y equals to pi by 4 and x equals to 1 in 3, we get when y equals to pi by 4 x equals to 1 means this term becomes cot of pi by 4 by 1 means it is pi by 4 only, which is equals to log 1 plus of c. So which implies 1 cot pi by 4 is 1, log 1 is 0 plus of c, which implies c equals to 1, right? The value of c is 1 here. So put the value of c in 1. Put the value of c in equation 3. Let's see what we get. Cot y by x, which is equals to log x plus 1, which is nothing but our required solution of equation 1, right? So next final example of this lecture. Today we conclude with this example, homogeneous differential equation. So it is example 4 here. Example 4. Solve the differential equation. Solve the differential equation dy by dx minus y by x plus cosec y by x, which is equals to 0, right? Given that y equals to 0 when x equals to 1, right? It has been asked in CBSE 2009 also, right? The solution, we have dy by dx minus y by x plus cosec y by x, which is equals to 0, right? So now which I have converted it in the standard form, it becomes dy by dx, which is equals to y by x minus cosec of y by x, which is equals to, so already we have taken here, so right? So not equals, it is. So take it as equation 1. Now it is in the standard form, right? So now put y equals to v of x, so that dy upon dx, which is equals to v plus x dv upon dx in 1, we get. Let's see after substituting in equation 1 what we get. When dy by dx means v plus x dv by dx, which is equals to y means vx upon x minus cosec of vx upon x. Here x get cancelled. What we get here? X dv by dx, this term as it is. The next step we will take this one. So here x get cancelled, v remains. Here also x get cancelled, minus cosec v, which is equals to x dv by dx, which is equals to v minus of cosec v minus v, right? So plus v minus v get cancelled. Remaining value is x dv by dx, x dv by dx, which is equals to minus cosec v, right? So now separating the variables here, separating the variables, then we get dv upon minus cosec v, which is equals to dx upon x. So now integrating, we get integration of minus keep outside dv upon cosec v, which is equals to dx upon x, right? The remaining I will write here. So what we get here, minus 1 by cosec can be written as sin v dv, which is equals to dx upon x, right? So integration of sin v is minus cos v, so minus minus plus becomes cos v, which is equals to log x plus of c. So now substitute, take it as equation 2, put y equals to x here, right? So what we get, cos of y by x, which is equals to log x plus of c. Now put given value, that is y equals to 0 and x equals to 1 into, so what we get here, cos 0 by 1 is cos 0, which is equals to log 1 plus of c. So cos 0 is 1 here, log 1 is 0, therefore c equals to what? The value of c is 1. Now put the value of c into value of c into, then we get cos of y by x, it is equation 2, right? This one is after substituting the value. This is equation 2. Cos of y by x, which is equals to log x plus of 1. Hence that is nothing but our required solution of equation 1. So